Rubber tapping begins at dawn. The work requires precise skills because if the cut is either too deep or too thick, the tree will be damaged and its productive life would be reduced. To get latex, which constitutes about 10% of all natural rubber produced, the collection is strained and concentrated. Depending on the quality of rubber, they are classified as RMA 1, 2, 3, 4 or 5. The water is removed and the end product comes out as latex sheets. Rubber sheets are smoke-dried and packed in bales of 50 kgs. A large bulk of this rubber goes on to make tires that crisscross the world. Tapped from trees in peaceful plantations, this wonderful, pliable, adaptable material is born to run. More than 250 raw materials are used in the making of a tire, and all these come to the raw material stores. At JK Tyre, each batch is tested first and matched against the supplier's readings. The major components are natural and synthetic rubber, nylon tire fabric, bead wire, carbon black, reinforcing non-black fillers like silica, vulcanizing agents and antioxidants. Procurement is done only from manufacturers with proven capability. When all test results comply with JK Tyre's stringent specifications, the batches of raw materials are marked and sent to various production lines. Chemical compounding and mixing of raw materials takes place in the giant multi-level banburies. Dozens of different types of chemicals and compounds of varying properties are mixed together vigorously to form a homogeneous compound which would display all the required properties. Computers measure and feed exact amounts of each component for the different kinds of rubber compounds that are made here. The soft polymeric materials, natural and synthetic rubber, and powdery components like carbon black and other chemicals are masticated vigorously together inside the banbury. The master batch, thus prepared, will be a homogeneous mix. To this master batch, curatives like sulfur are added. So are accelerators that will speed up the vulcanization process to come later. and retarders so that the rubber remains supple right up to the curing stage. Further chemicals go in to increase the shelf life of the tires. Among the different kinds of rubber compounds made here are cut-resistant rubber for OTR treads and sidewalls, and rubber with low air permeability for tubeless tires. For OTR tires, silicates are added along with carbon black to heighten the cut-resistant quality that is essential for these tires. The output is seen in the form of sheets, which are then cooled and stacked as the final batch. Samples from each batch are taken to the mill room control laboratory, where the rheological properties of the rubber compound are checked and released to the respective sections. Nylon fabric is used in the tire to impart strength. JK Tyre uses grey fabric, the strongest cords in the industry. The nylon tire cord is dipped in resorcinol formaldehyde latex or RFL solution, which also contains various stabilizers. The fabric now changes color. The thin coating of resin allows for better adhesion of the nylon cord with the rubber compound in the calendering stage. Here, in the computer-controlled Zell plant, the nylon cords are aligned symmetrically along the longitudinal axis to best handle the operating stresses on the tire. Special rollers are used to maintain uniform ends per inch in the dipped fabric. The fabric is thermally set to maintain the dimensional stability of the cured tire. The dimensional parameters are continuously monitored by state-of-the-art electronics, and fluctuations are corrected. Such continual checks ensure that all inputs that go into a tire are faultless and meet the high standards that customers have come to expect from JK Tyre. The building block of a tire casing, the ply, is made at the calendering stage. Fabric calendering takes place in the 4-roll calendar. To increase the durability of the tire, all the plies must react in unison to flexion under load. To ensure this, the dipped fabric from the Zell machine is coated on both the sides with rubber compound taken from the same batch. The dipped fabric passes over a photoelectric auto-centering device. A bow bar guards against creasing, and two trio canters prevent end bunching when the dipped fabric is fed into this massive machine. The calendared fabric is strictly gauge controlled. Continuous supervision ensures uniform and correct thickness and results in a very low rejection rate for these high-technology tires. Fabric color thread identification helps in immediate recognition so that the specific calendared fabric goes to the specific tire. The calendared fabric is cooled to room temperature to avoid thermal warping. From the cracking mill, which softens the Banbury's final compound, through the feed mill that creates specific widths and thicknesses, the rubber compound comes for the extrusion process. In the single-line extruder, the rubber compound is forced through a die to make single compound rubber parts like sidewalls and also the apex or filler, which we shall get to know at a later stage in the bead room. The extrudate is then dispatched to the tire building and bead making sections of the shop floor. OTR tire treads consist of a cap and a base, which have different properties. These treads are manufactured in the dual tread extruder machine. The cap is what comes into contact with the surface of the road and therefore has to have essential qualities that deliver JK Tyre's promise of total protection. The base is soft and has very high heat-resistant properties because it has to retard heat transfer from the cap to the casing when the tire is in motion. At the end of this process, a thin film of polythene is applied under the base to prevent contamination by dust, dirt or water. The tread is cooled to room temperature and dried. After this, the tread is cut to required length, depending on the tire size. The statistical process control station tests the treads to see if they conform to the weight and dimensional specifications for each type of tire. Calendared fabric comes to the fabric cutter, where each color-coded fabric is cut at a specific angle or bias for specific tires. On the factory floor, a protractor sets the specified angle for cutting. Experiments at JK Tyre's Research and Development Wing have resulted in precise bias angles for particular tires, depending upon the application they are put to. Smoothness in running is measured against traction and strength, and the optimal angle is determined for OTR tires. The bead supports the weight of the vehicle and makes up the backbone of a tire. The bead wire is a high-tensile steel wire coated with copper. Several strands of bead wire are coated with a tough rubber compound through a cross-head extruder. The number of wires used and the number of turns of the wire dictates the bead safety factor, and this varies from tire to tire and is determined by specific on-field requirements. The wound bead and the apex from the single line extruder now come together. The apex is fixed on the top of the wound beads so that the bead of the tire mates perfectly with the rim contours of the vehicle's wheel. The apex distributes load across the width of the bead and forms an airtight seal with the rim. This is a fillered head. Making a cover for the bead bundle is called flipping. This cover is a calendered fabric and is wrapped over the wound bead